So now we're going to do a problem for 8.3, and I'm going to put this up here. Okay, so we're doing one proportion test. That's what we call it. Okay, so this problem is based on information from the Merck manual. So there's a commonly prescribed drug for hypertension. However, the drug causes headaches in about 12% of the patients using the drug. It is hypothesized that regular exercise may reduce these headaches. So the random sample of 215 patients using the drug exercise regularly and only have 17 headaches. Would this indicate a reduction in the population proportion of patients having headaches? Use the 1 level percent of that significance. All right, so let's look and see what we've got. All right, so the first thing it wants me to get is it wants me to do the level of significance. Okay, so it's 1%, or I'm going to convert it to a decimal. Okay, so that's your level of significance because it's right here. Okay, and I'm going to put that in yellow again. All right, so what other stuff have I got? I've got here that 12% of the patients get a headache, and I've got a random sample of 215 patients, and then only 17 of these 215 got headaches. Okay, and then it says, would this indicate a reduction in the proportion of people having headaches? Okay, I'm going to do this in a different color, and I'll show you why in just a minute. Okay. All right, so let's go down here. All right, and it wants me to do, let me get out of this. It wants me to do my null and my alternative. So I'm going to do HO, it's my null. H1 is my alternative. Okay, for these, I'm going to do it as the special P. This is not the same as p-value. This is proportion, okay? So again, my null is the equal sign. And if I go up here, I had 12% of the patients. So another way to write 12% is 0.12. All right, for the alternative, it wanted to know, and I'm going to show you right here, it wanted to know if it reduced it. So this is a less than symbol, and again, it's for the 0.12. Again, nulls have the equal. Alternatives either have to be less than, greater than, or not equal. So those are my hypotheses. So if I look here and match up the ones that are correct, let's see, is that one correct? Yep. So this one is the correct hypothesis. All right, so I'm going to keep going. Okay, so why are we doing this? So remember when we did proportion, this is a standard normal, but it follows different rules because we're using proportions. And remember the rule was that n times p had to be greater than 5 and n times q had to be greater than 5. If that's not ringing a bell, go back to the proportion intervals and that should help. All right, so now it wants the value of my test statistic and my p-value. All right, well, I'm gonna go back up here so I have all my information for me. Oops, let me go back here and let me bring up my calculator. Okay, turn it on. And then I'm going to go to stats, go over to test, and then I'm going to go down. For me, it's 5. It's called a 1 proportion z-test. Remember, 1 mean z-test we were doing for means. This one we're doing for proportions. So I hit enter. All right, the p with the little o is going to be the 0.12. Okay, that is like the proportion that I'm using for the whole problem. X, okay, so think of it this way. N is your sample size, and X is a portion of that sample size. X always, always, always has to be smaller than N. I know that's crazy, but it will give you wonky stuff if you do it the reverse. Okay, so I've got my 12%, which is here. I've got my 17, which is here, and I've got my 215, which is here. All right, remember I said down here it was less than, so I'm going to go here, oops, go down, and I'm going to hit over here, and then I'm going to hit enter so it blinks at me. Then I do calculate. All right, I get all my information, so let's go down and put it in to make my life easier. Okay, bring it back up. What was my sample test statistic? So I'm looking for this number right here. Z equals negative 1.846. It wants 2 decimal places, so I'm going to put here Z equals negative 1.85 because I rounded. And then my p-value, let's go back. P-value is 0.03238. It wants 4, so I'm going to round up. So p value equals 0.0324. Okay, so I have everything I need right now, and I'll come back to it. All right, so remember this was a less than test. So I'm looking for areas to the left, and here's it is. Okay, I don't care about it being above it. I don't care about two tails. Remember that one I'm not worried about. I want the area to the left. All right. So am I going to reject my null or fail to reject my null? All right. So remember my p-value. Value was 0.0324. And my level of significance was 0.01. All right, so let's compare them. So P is 0.0324, and my level of significance is that. So I'm going to add more zeros. Oh, look, this one is greater than it. Because my p-value was larger than my level of significance, I failed to reject my null. Cool? All right, so what does that mean? All right, so let's go back up. And I forgot to do one step that I did before. Okay, this was my original claim. How do I know it was my original claim? I'm going to show you because I did it as my green, so the greens match up. Okay, so I failed to reject my null, which means, oops, my null is true and my original claim is false. All right, so that's showing me that, hey, something's going on. So my original claim is false. That means it's not reducing it. That's all I can say. I can't say it's increasing or it's the same. All I can say is that it's not reducing it. All right, so I'm going to go down here. Okay, remember, so we said I didn't reject my null. I didn't reject my null, but I did fail to reject my null. So my data was not significant. Okay, again, I failed to reject my null, which means my null hypothesis was true, but I was testing my alternative hypothesis. All right, so then at the end, so what can I say? So I'm going to put it up here. Let me do this. Sorry, this is taking so long. Whew, my computer's mad. All right, come on. I'm going to do this. I'm going to take these down here because I think it might help if we see it by each other when I finish this up. Okay. Oops, come on. All right, I put my hypothesis down here just so you can see them again, so it'll make sense when I explain this. Okay, so, all right, remember I looked at my original claim and it was false. So because my original claim is false, oops, hold on, hopefully it'll come back. Let me close stuff down and see if my computer will come back. It's spinning on me. Okay, let me close this down. I think I have too many things open. Close window. So it's here. It's this last one, if you can see it, there is insufficient evidence at the 0.0 level to conclude. Why? Because I didn't support my original claim.